Check your understanding problem number 2. Once again, try this problem if you haven't already. At least try to draw the picture, label one of the sides, see if you can find any other missing angles or other missing sides, and then see if you can find these trig ratios using what we know about which sides each trig ratio relates together, and then see if you can come up with the fractional values that represent those ratios. So try that, pause this video, and then hit play again when you're ready to check your answer or if you get stuck. So once you're ready to begin, we're going to draw a picture. We see this right triangle that has a 30-degree angle. This will be our short leg that is 3 units long. This is all we're given, but we know if this is a 30-degree angle, that this must be a 60-degree angle. Because 30 and 60 makes 90, this is a 30, 60, 90 special triangle. So the hypotenuse is going to be twice as big as the short leg, so that would be 6. And the long leg is going to be the short leg times the square root of 3. So 3 square root of 3. Now, let's find the sine of the 30-degree angle. So if 30 degrees is my focus angle, and I'm doing sine, if we think about our phrase to help us remember, whether that's SOHCAHTOA or something else, we know that we need the O and the H when we're talking about the sine. That's the opposite and the hypotenuse. O over H. So the opposite of the 30-degree angle is a triangle. That would be the 3. The hypotenuse here would be the 6. So we get a ratio of 3/6, just 1/2. So the sine of 30 degrees, we can now say for is 1/2. And a triangle that has a 30-degree angle, sine of that 30-degree angle will also be 1/2. That means it's the opposite side. 5 side would be. And that makes sense because we know that the short leg times 2 is going to be, and that short leg always will always be at the opposite of 30 degree. Let's go to the next the cosine of 60 degrees. So now our focus angle has changed. We're not focused on this one. On this focus, now we're focused. Cosine involves two sides. The part of SOHCAHTOA, or whatever you need to remember that. So the adjacent and the hypotenuse are going to be the sides we focus. Which side is adjacent to the 60-degree angle? So that's the right leg right here. We thought that way. And then the hypotenuse is 6. So the ratio, this cosine of 60 degrees, that's the thing we've seen before. That's the exact same sides compared with the sine of 30. So interesting. Sine of 30 and cosine of 60 are both giving the same thing, talking about the same sides angle, right? So just jump there, note there. Now part. The tangent is 60 degrees. Tangent is opposite over adjacent. The opposite of the 60 degree angle across the triangle here. The square root is 3. Adjacent side, we saw this a minute ago. That's the 3 leg. And if I look at if I see a 3 at the top and a 3 factor on the bottom, those can cancel, just leaving 1 the square root of 3. So the tangent 60 degrees is the square root of 3. What does this mean? Well, this just means that the opposite side of the 60-degree angle is always square root of 3 times as big as the adjacent side. Okay. Build that ship that we saw before, right? Compares the opposite to the adjacent, and since the tangent that compares the opposite and adjacent, since the tangent of 60 is the square root of 3, that means this side must be the square root of 3 times whatever our leg is. Okay. Now let's go take a look at problem number 3 as well. A right triangle has an angle that is 45 degrees and a leg that is 5 units long. So right triangle, 45-degree angles, which tell me that this is also 45. and a leg that is 5. Tells me that this is a 5. And while we're at it, tells me that this is going to be the 5 squared. Okay? Okay? We've got the whole triangle already laid out. Now let's just see what it's asking us for. Find the tangent of 45 degrees. Tangent of 45 degrees. A tells me tangent is the opposite and the adjacent. Now we have two 45 degree angles here. Is it going to matter which one we pick? Well, the opposite of this 45 is 5, and the adjacent to this 45 is also 5. So we get 5 over 5. True have been true from the other one? Yes, it would. The opposite is 5, and the adjacent to this one is 5. Either way, we're getting 1. So the tangent of the 45 degrees appears to just be 1. Will this always be true, no matter no leg length? Yes, it will. It will. Yes, this is always true for the tangent of 45 degrees. But this is going to be true about the leg lengths. If I make it of this side of 10 and it's a 45, 94 triangle, this side will 10. Because the tangent will equal, in this case, the length over leg length. And if those are the same, it's always going to be 1. Okay? It works no matter which 45 degree angle you're looking at. Okay. So that wraps up our lesson here. Make sure this for you before you move on to the next one. The next activity you will be needing to get a copy of that paper and a jumbo paper, and you're just going to poke that through. I'll show you in the next video how you get that set up and how we start to make sense of connecting the ideas, not just with triangles, as we start to look at circles and start to build on this understanding of ratios and angles within circles as well.